Okay, I'd like to make a discussion about ellipses. Ellipses are one of the conic sections. So you can imagine a cone and cutting it, chopping it down the middle by a plane or something. Then on that plane, the intersection with the conic section is an ellipse. So the intersection of a plane and a cone is an ellipse. There are other ways to cut the cone. For instance, if we cut the cone vertically with the plane, and it makes what's called a parabola, I believe. Parabola. And if we slice the cone in just the right angle this way, with the lines lining up, so it comes. I seem to be having trouble drawing this, but so that this plane is parallel to one of the edges, we get something called a hyperbola. And generally, when you get a parabola, if you extend the cone downwards so that you get a double cone, you get two parabolas. Wait a second, no, that's not right. Sorry, I got these backwards. This is these are hyperbolas. These are parabolas. You get two hyperbolas or one parabola, because this can extend down and cut that other cone too. You get two hyperbolas, so it looks. So a couple of examples of hyperbolas is kind of look like this, or you can put them sideways. This probably is simplest description of a hyperbola is this one. Y equals 1 over x gives you a parabola, or I mean hyperbola. On the other hand, the parabolas go y equals x squared, and another these hyperbolas up here are described by x squared plus y squared, or let's say x squared minus y squared equals, say, 1, or y squared minus x squared equals 1. In fact, both of these would be described by y squared minus x squared equals 1, while both of these would be described by x squared minus y squared equals 1. And of course, you can change this this number to change where it crosses the axis. Now, Mathematica can show us some of these shapes with a contour plot. Here's the shape that is described as x squared plus y squared equals 1. If I change this to a minus, you can see a pair of hyperbolas going horizontally. And if I change both of those signs, so there's minus x squared plus y squared, you'll see the hyperbola going the other direction. Also, if I just have, say, x plus y squared equals 1, what happens then? Then we get a parabola. And if I said x squared plus y equals 1, then we get a parabola going horizontally. Of course, I can change that to a minus, get it popped up to the normal way of seeing it, which notice this has a intercept down here at -1. If I change that to 0, it'll pop up to the 0 point. Okay, but the focus I had earlier was ellipses, and ellipses are kind of like circles, so let's go to the circle shape. x squared plus y squared equals 0. That doesn't have a radius. We need a radius in there. Now it's got a radius. Okay, an ellipse is like a circle, except it has one of the axes extended. So if I want to extend the horizontal part of this, I'm going to divide that by, let's say, 4, and I'm thinking that will make it extend all the way across. Yeah, so now we have an ellipse with a major or longer axis of 2 units and in a minor axis, I'll draw it that way, minor axis of 1 unit, or is it 4? And yeah, the major axis here is 4 units, sorry, because it goes from -2 to +2, which is not visible on the screen there. Okay, so this is 4 units, and the minor axis is 2 units. But we don't usually talk about the major axis and the minor axis. Instead, we talk about the semi-major axis, which in this case is 2 units, and the semi-minor axis, which is going to be 1 unit. Now, if I had 2 thumbtacks and a piece of string, so these are my 2 thumbtacks, and I have a piece of string tied to both of them, and a pencil. Let's see, so I need a string and pencil, and I'm going to put the pencil right here, and I'm going to take the pencil and draw around this circle what I will end up with, or draw around, keeping the string tight all the way around. What I would end up with is an ellipse. Now this length of string, when I stretch it out completely one way, you can see something. If I had it come that way, where the pencil is, and back to here, then we double up the length of this, and that length that is doubled is equal to the length over here. So the string length is the length of the major axis, or 2 times the length of the semi-major axis. And I'm going to just define this variable a, that a is the length of the semi-major axis. Now there's another feature of the ellipse called eccentricity, and it's usually denoted E, and E is a variable that it would be easy to define if we defined some other things first. If we define the distance between the 2 thumbtacks, and right now I'm going to call it D sub f, so which stands for distance between the focuses. Distance between, or foci, and the eccentricity is equal to the D sub f over 2a. So let's look at 2 examples of this. One with a perfect circle, both thumbtacks. If both thumbtacks were placed at exactly the same point and the string was tied to them, then and then moved around, it would make a perfect circle. The distance between the foci would be 0, and 2a would be the diameter of the circle. So basically E would be 0. So perfect eccentricity 0 represents a perfect circle. Now, another example is where I take the thumbtacks, or rather, I take the piece of string and put it in a straight line, put one thumbtack over here, and the other thumbtack over here, and then I just move my pencil along from one end to the other, and what I would get is a straight line. Here, the distance between the focal points is equal to 2 times the semi-minor axis, or the length of the string, and we would have d sub f over 2a is equal to 1. And that is the situation where you would have basically a straight line. This discussion will be continued in my next video.